That's fine.
Nice.
All right. How's everybody doing? Good. Good. Fabulous. Calvin's busy. Doing good. All right. So I guess let me start off. Were there any questions specifically about last week? I know it was a lot of here's how the class works and first assignment kind of stuff, but everybody submitted, I saw, or just about everybody, so I'm assuming everything's good. Okay. So this week, what I'm going to kind of go through is, last time we kind of talked about here's what it looked like in Java, here's what it looked like in C#. I kind of gave you the impression that most of C# should syntactically look similar to Java. But I'm going to give you examples of each one of these pieces and functions. So go through declaring variables, go through declaring objects, creating instances, arrays, creating instances, go through the procedural processes that exist or procedural calls, the logic flow, and just kind of give you an overview of what the language is. So that'll probably end up being the first hour. Then the second hour, we'll go into more detail of trying to apply those actions and doing some calculations and doing some basic work. The homework for this week will be to create a command like calculator. Now, some of you guys went in and created calculators, and the way that I saw most of them done was you would prompt for a number, prompt for an operation, prompt for a number. What I want you to be able to do is to do natural language type. So what that means is that the application launches, and it comes up and says, give me an equation. And then I type in 2 plus 2. Hit enter. 2 times 2. 5 times 10. Whatever it is. Hit enter. It doesn't have to be a complex equation, but be able to do something as simple as typing 2 plus 2, hit enter, and let the computer figure out what that means. Do the operation that you asked it to do, and give you the answer. So it seems very simplistic, but it's relatively more work, especially when you get into numbers that are above 1 digit. If I put in 100 times 100, you have to figure out where does the number stop and the operation begin, and where does the operation stop and the number continue. And is everything that I put on that line actually equate to a number or equate to an operation? So we're going to kind of talk about how to make that happen a little bit today, but I'm not going to show it to you because that's why it's homework. But that'll be your goal. I'm going to give you the tools and approaches that you can use in that application, and that'll be the homework for the week. So again, at the end of class, if you want to work on it, that's cool by me. I'm going to basically give you an hour to hang out, work on it, ask questions. If you prefer to do it at home, that's fine too. I'm available. Also, as a rule, just a general rule of thumb, anything I assign you is due at the end of the next class. So the homework from this week would have been due or is due at the end of this class. I do that because homework is something you take home and do as work to learn. You take it home, you do the work, you have no idea what happened, but you couldn't get it to work. It happens. I'm here as a resource. I want you to come back to class, ask questions, spend that hour maybe talking about the homework from last week, getting some questions answered, and then submit. So, is that fair to everybody? Okay. All right. So I'm going to use this void main statement or function just as my playground. I'm just giving you the different examples. I've got it all commented out here below. I'll move the comments up as I go through the scenarios. You're welcome to follow along, but like I said last time, my main goal is for you to watch and ask questions, and then if you need to watch it again and you miss something, I've got the recording going so you can do that. All right, so we'll start with procedures. So function definitions, actually I'll move this down, back down here. So function definitions basically come in 2 or 3 sorts. A void function is a function that does not return a value, and furthermore usually does not have a parameter. If you're familiar with VB or VB.NET, they're usually called subroutines. And basically it's performing an action in isolation. These functions normally either do some sort of a task that utilize variables at the class level. Since you're not passing anything in or out, it's basically doing something that's making a modification to the class. So, for example, if you created a class to do your calculator that had 3 variables, 2 numbers, and an operator, you would plug in those 3 variables, and then you would probably run the add method. It would then take those 2 numbers plus the operator, determine if it's supposed to do add, do that logic of adding the numbers together, and then it would probably store the result in another variable that's part of the class. So subroutines basically do those functions, or do those types of actions. If you were to call, so we dealt with the console class last time, and we used the console write or write line. Write line has an overload that is a void function. It doesn't take in any parameters. It doesn't return anything, but what it does do is it writes a blank line out to the console. So that's a little bit of a different scenario, but again, does the same kind of work. So to do these, they're pretty simplistic. It's just void, and then we'll say function name, and then 2 parentheses, and then the body of the function. Okay, pretty straightforward. If we're passing values into the function, then that's a parameterized function, and I'm going to overload the same function, so I'm going to use the same name, but I'm going to give it a different set of parameters. So by doing that, I've now made that same function parameterized. So I have parameters as part of the function, first name, last name. The third option is basically a function with a return value. And the return value is where you say that there's a particular type of value that's going to be returned from this function. So in this case, we'll just go with a string. And we'll do my function. And again, these can be with or without parameters. So this function in this case would do some sort of task. And then because I gave it a return type of string, the compiler will yell unless I have a return in my function. So if you notice with the void ones, I wasn't required to put a return value in here. With the ones that have a return type, I am required to put a return value.
So a function is the same thing as a method?
Yes. So yeah, terminology-wise, some people call them methods, sometimes they're called functions. Generally, the difference is that it has to do with the origination of kind of what you call them. Methods, the terminology I've always used is that a method is part of a class. And that kind of came out of the difference between C and C++, where C doesn't really have classes. They just have methods or functions, and you just call functions from within your code. Where when you define a class, that class has methods or actions. So sometimes the word method and action are kind of used synonymously. So I use them interchangeably depending on what I feel like saying. So, but they are the same thing technically. Okay. So with this one, we could say return first name plus last name. So this function would basically do the concatenation of the strings. Okay. So pretty straightforward. Hopefully it's now that you see it, it's like, oh yeah, that's just like in Java. So nothing fancy. So after that, we have variable declarations. And again, just like in Java, what you would see is you start off with a variable type. So be it an integer, a long, a string, a float, date, time, whatever sort of class name that you would want to use. If you're declaring a variable that's of a particular type of class, you would put that in here first. So int age, semicolon. It's a basic declaration of a variable. We can do string. We'll do last name again. And you can also declare them that way. So we declare the variable of type string, so a string of last name, and then we set it or initialize it to an actual string value, which is in quotes at the very beginning. Object instantiation or class instantiation is basically the same idea. The only real difference is that you would use a new statement when you're initializing that class. So let me think of a class that I can use. So in the system.data namespace, there's a data table class, which is supposed to represent a database table in memory. So just as a little side note, so you can actually pull data out of a database, store it inside of a data table, and it's an in-memory version of that database table. It's disconnected from the database. So if I wanted to create one, I call it DTMyTable, giving it a name, and that's just simply the declaration. So that variable is declared. The value of it is null. So if you remember from last week, we talked about by value, by reference. All class declarations are by reference, because way back when they're part of the heap and they're allocated dynamically. So by declaring this variable, I've declared the variable, but it's not set to anything. It's a null variable. If I try to reference it or add something to it or do any sort of method calls that exist, I'm going to get a null reference exception because it's null. It's basically pointing to no memory space. It's just the symbol that's out there that doesn't really mean or do anything. To make it do something, you have the you actually have to set it to something. So we'll set it equal to a new data table. Oh. Oh, okay. This is because of scope. I'm doing it inside of a class instead of a function. So let me move it up here. And I'll move all these up here. Okay. All right. So now that we've said new, and basically this says new data table, I'll add a using statement. So my data table equals a new data table. So I'm going out to the heap, I'm allocating that space for that data table structure, creating it in memory, and it's passing me back a pointer, so that concept. So this variable, DTMyTable, is now instantiated, it's now an instance. It actually has, so it's pointing to a memory space, it actually has an object out in memory that it's now referencing. Yeah?
How do you connect to a database? We're going to get that later.
I'll get to that later. Yep.
Data table some sort of like data structure that's pre-programmed into?
It's more sophisticated than a data structure. You're thinking of things like arrays and linked lists and things like that. These are much more sophisticated than that. They use those concepts, but it actually represents a data table with rows and columns, and each column has its own data type and all of that stuff. So it's significantly more sophisticated than like a linked list or just an array or something. So.
Okay.
Okay. So I'm going to pull the rest of these up because they all will function within this. Okay. Array declarations are basically the same or similar. You start off with the type that you want the array to be. So we will use a float this time. And then to designate it as an array, we just put 2 square brackets, open and close. And then give it a name, semicolon. Now, something that's very unique about arrays inside of C# and .NET is that all arrays, even though this is a float array, which a float is a primitive or a structure, all arrays are by reference. because all arrays under the hood inherit from system.collections.array. Oh, sorry. Nope, system.array. So all arrays, even though they're declared like this above, actually inherit from this class structurally. They get all their functions or methods, they get all their properties from that base class. Now the runtime does all that for you. It does that inheritance by design when it compiles. But just so you know that that is actually a class, it's not a structure. So to create an instance of it, you will say myArray equals new float, and then you actually define the length or size of the array at this point using square brackets. So we'll say 10. So now myArray is instantiated with 10 blocks of memory, 10 floats. Those values start at 0 to 9. So just like in Java, you don't start at base 1, it's base 0. So the first position of myArray is 0. Second position is 1, and so forth. And then to create instances in these, you would just say and then the F designation says take this integer and assume it's a float. So that's a compiler thing. If you don't do it, I think with floats it's fine. With doubles and stuff, you'll run into issues where it doesn't like it assumes that it needs to be a floating point value, so you have to use the F designation. All right. Any questions on that? One other way that you can do array declarations, if maybe you're declaring an array of strings to do some sort, you're just acting it as a list, something that you're going to use within your application. You can declare them this way. And you're basically pre-initializing that array. Okay, so this is the equivalent of saying my list equals new string 5, my list 0 equals January. Etc. So it's the equivalent syntax of that. Saves you quite a few types and keystrokes. Alright, so that's the basics around declaring variables. I think most of you guys get that based on the homework that was submitted, but those are the underpinning concepts. Those are some of the things that you may run against and go, is that the same or not? So, if statements are pretty normal as well. So you start off with if, parenthesis, and then this is basically your logic statement. Okay. You can also do else ifs, which is basically just chaining if statements together. So you can say else if okay, so you have that ability. Yes, so that's actually a good question. So if we wanted to do something that was a Boolean logic, you can do this and datetime.now day of week equals so you can do that. Or statements are or. Okay, and then the parentheses and everything, so you can block them together, so we can say something to the effect of, if the date is less than 15 and it's a Monday, do this, or if it's a Tuesday, do this. Nots are the same as well, so if you want to do not equals, you can do it that way. And if you want to, you can also do it this way, where you precede it with a not, an exclamation mark, and then put this in parentheses. So that also does a not equals. So switch statements. I noticed nobody used a switch statement, and there were some scenarios. Are you guys familiar with switch statements at all? Yeah, usually it's used with enumerations, and I think that was a limitation in Java, was you could only use it for enumerators. Inside of .NET, enumerators actually give you even more, enumerators. Switch statements give you even more flexibility. You can use it with just about any primitive type. So your strings, your numeric values, I think even date times, you can use a switch statement. So if we declare a variable, or we have one declared up here, last name, we can do a switch statement that says switch last name, which is a string, and then a case. So if last name matches this case, Gantos, colon, do work. And then to break out of the case, you do a break. So what this declaration block says is, I want to do a switch on this variable, last name, and if the case, which can also be interpreted as if last name equals Gantos, then do this block of work. Once it executes that block of work, you have to then follow it up with a break, which then breaks you out of the switch. It's required, and the compiler will yell at you if you forget to do a break. I don't know if Java yells at you if you forget to do a break, but I know with prior languages like C++, if you excluded the break, then the code would just continue and fall through to the next case statement and execute that code as well. So it was kind of an interesting scenario. So let's say you wanted to do case Smith. You can then do work and a break. Case Roth. Do work and a break. These are handy when you have a lot of if statements that you need to do in series. So instead of saying if last name equals Gantos, do this. If last name equals Smith, you just basically say do a switch on this variable, put in your equals to's, and then have your little function call or whatever, a little step of work you need to do, be in that block. With numbers, it's basically the same thing. You put the number variable at the top in the switch, and then your case looks something like case, I'll just do it down here, case 1, case 2. Okay, so it's basically the same syntax. There is another special keyword that you can use here, and it's called default. And what default does or says to the computer is, if none of the cases match, do this work. So it's basically your else statement, if you want to think of it that way. And you also have to follow it with a break. You can actually group case statements together as well. So we could say case is Smith or case is Jones. In both cases, do this block of code. So that would be kind of like an AND if you were doing an if statement. Yeah, so they give you some flexibility if you have a lot of chained together if statements, as you can see, but they're also limiting if you have complex logic. So if you're doing something sophisticated where you need this or this, you don't really get that flexibility within here. So you kind of have to tender, is this a good approach versus the other? They each have kind of their pluses and minuses, as all things inside of programming do. So, all right. So, any other questions in terms of like logic control and things like that? Those are generally the two big ones. Okay. Loops. So we have for loops, for each loops, while loops, and do loops, or do while. For loops are pretty straightforward. You can say for int I equals 0, semicolon, I is less than 100, semicolon, I plus plus, which is the enumeration. Do work on I. So, starts at 0, runs to what value? 99. And then we'll exit the loop. Generally, you do some sort of computation either with I or you keep track of I to make sure that you don't exceed it. So those are pretty normal. That's kind of like programming 1, right? Okay. For each loops, Java has for each loops now, I believe, right? Okay. So if you have an array of strings, which are names, or if we have any sort of collection, we can have a list of a list of exceptions. We can do a for each exception, and then we give it a local name, E, in exception collection, and then inside of here we do work with E. Okay, so it allows you to enumerate or go through each item individually. Is there a colon in Java? Okay. Okay. So that's a little easier to read than, a colon. So you just can say this in this. So yeah. So then from here, if we wanted to, we could do console.writeLine e.message. Stack trace. Cool. All right. A while loop is basically the same thing. So while true, do this work. So you basically go through this loop, and as long as that logic statement is true, which in this case it's always true, then the loop will continue to execute that code recursively or sequentially. If you wanted to break out of the loop, you use break. Yeah, so yeah, if you got stuck in your loop, you would want to use a break. So normally you would see it in if x. Okay, do it this way. If x, break, else do work. Okay. Is there anything unique around that declaration? Yes. So I used var. What? What was that? So some people will tell you that, but it doesn't. So traditionally, all data types from within the .NET framework all inherit from object. All right, so if you want to capture a value into a variable and you don't really know what type it's going to be, object is always your best container because it's always the root container. Every class in the framework inherits from object. Okay? When you declare a variable var, what the compiler will do is when you use var, you're required to instantiate that variable on that line. So if I try to just declare x like this, it'll give me a little error and it says implicitly typed variables must be initialized. When you use var, it's basically a shorthand where you're not, instead of typing out that data type, like this one is a Boolean, so instead of saying bool x equals false, it infers the data type from the initializing value. So by saying var, it says, okay, I'm going to declare a variable called x. I don't know what the type is. I'm going to look at the piece on the right of the equal sign and figure out what data type that is, and then infer it and declare x as that type.
So if you put like quotations, that's a string.
Yes. So if you put quotes, if you put something in quotes, it becomes a string. X becomes a string. If you put a number out there, it becomes an integer. If you put a floating point number, it becomes a float.
Can you change it like, say, right there it's a Boolean.
Yep.
But what if it becomes like, say it's a string?
So if I go in here and call it false, like that.
There it thinks it's a Boolean and then it's actually a string.
Right. So I'm going to get now, it says cannot implicitly convert a bool or a string to a bool.
Okay.
So they're cool and they're good to use in very small chunks of code. So if you're running within a method or a loop or something, you need a kind of quick and dirty declare a variable, they're good to use. But if you really don't want to use it outside of a function or outside of maybe a chunk of a loop or something like that, because if you declare a var variable in a class and then you decide to go back and change that declaration, anything that touches that var variable will then be affected. So going from a bool to a string, you'll probably hose yourself up and be there for about a half an hour trying to go back and fix everything. So it's a good little shorthand, but use it sparingly. On the note of the object, if I were to take obj and put it in here, obj will give me an error as well. And in this case, it's saying that it cannot implicitly convert object to bool. And that's because it's a generic container. It's very broad. So it doesn't know inside of that object variable what type of object it is. So in this case, you would have to explicitly cast it. And casting, just like in Java, is you put in parentheses the data type in front of the variable name. So the compiler will now take obj and cast it as a bool. A do loop, like a while loop, is basically, so a while loop says, if this is true, run this chunk of code and then visit me back again at the end. Loop back. A do while says, do this chunk of code, and then at the end you have your logical condition of, while this is true, do that chunk of code again. So in this case, you would do while true. So the only real difference is if I declared a variable out here that was a Boolean, and I made this is true, versus this one is true. If I were to set this to false, this would never run. This would run once, because it doesn't do that logical observation until the end. So, okay. One other thing with regard to loops And normally you'll see this with for each. If we have a logical statement inside of here that says something like if E equals null, we can then not break from the loop. You could break from the loop. You could just break, which will exit the loop. Or you can skip this item and move on to the next one using continue. Okay. So if we've got 10 of them in here and the first one is a dud, it's null, there's nothing set to it, we can then just say continue on to the next one and continue through the collection without breaking and exiting the loop. So overall, those are the general concepts of what to do inside of C#. Those are the procedures, variable declarations, arrays, your logic and loops, statements, beyond and above, all of that. Like I said before, it's really around the structures and items that are in the framework and using those classes to do work in a nutshell. So, any questions or anything that maybe was in Java that I didn't cover in terms of equivalence? Okay, cool. All right. If you guys want to, go ahead and take a